Today we are going to present our smart stethoscope project with my teammates Eda, Furkan and Şeyma. In quarantine days, going to hospital and getting medical examination is quite risky and hard situations for heart failure patients. Unfortunately, number of heart failure patients increasing day by day all around the world. Using smart stethoscope and sending heart data to the doctor is reasonably cheaper and easier solution comparing medical examination. Scopes of our projects are getting heart rhythm data and with the help of AI algorithms, making diagnosis. According to diagnosis, mobile application shows an advice on the screen. Saving patients' heart data and sending them to the doctor. And in emergency conditions, having first aid call via mobile application. Heart sounds receiving by microphone and converting to electrical signals. After amplifying and filtering process, signal reaching to pocket beagle. With the help of Bluetooth module, heart data is transferring from pocket beagle to mobile application. Data are stored in a cloud server. When doctor wants to see patient's data, the program downloading data from cloud. In mechanical design, we decided to make a curved external structure design in order to make it easy to hold. And also, this curved design is much more elegant as compared to the previous prototypes that we draw. We choose material as ABS plastic for external structure and floors. ABS plastics are frequently used in home electronic devices. Further, they have high endurance to the impacts. The total weight of our design, including all electronic components, is approximately 265 grams. Weight of the handheld devices are usually below 1000 grams, so weight of our design is quite appropriate. As you see in the exploded view, there are two main external parts and three internal floors of the stethoscope. There is a PCB board on the first floor, MAX 4466 microphone module and op-amps soldered on the PCB board. In the second floor, there is a pocket beagle, and on the third floor, there is a battery cell. Also, a top cover added to design in order to make battery changing process easy. In designing part, our goal is reaching optimum sizes. In order to decrease prototype dimensions, we selected pocket beagle instead of beagle bone. Thus, we obtained these dimensions as you seen in the technical drawings. Height of our design is under 10 cm and diameter of base is 75 mm. The most largest section of the curve is 90 mm. There are technical informations about electronics and software sections of our project as you seen in the table.
To gather good quality heartbeat data, some circuits has been built. In the input of preamplifier circuit, signals come from electrode microphone in microvolt levels. It could be up to 100 microvolts. As a test signal, 100 microvolt AC signal given. We can see that at the preamplifier stage, gain is approximately equals to 20. In the low-pass circuit, the cutoff frequency is decided as 150 Hz, and components has been chosen based on this value. On the other hand, in high-pass circuit, cutoff frequency has been chosen as 20 Hz, and the components has chosen due to this frequency level. You can see the output of whole filter circuits here on the right. Lastly, output of the filter circuits comes to the driver amplifier circuit. In order to give a signal to ADC unit, we should take signals that have between 0 and 1.8 volts. Amplitudes of signals has decreased and the signal has shifted. After the signals converted into digital signals, they will be transmitted to the mobile device via Bluetooth module. Then they will be transmitted to cloud and process will continue in the cloud with digital filtering and AI classification algorithm.
In this chart, the signal must first reach the computer and then preprocess the signal. The model is trained using the data classification methods specified and the results are obtained with the test data. Wavelet scheduling. The translation creates invariant, stable, and informative signal representation. It is stable against deformation and maintenance class discrimination, making it particularly effective for the classification. Digital filtering. After filtering the circuit, it may be exposed to environmental noise during communication or the process when the signal reaches the computer. In this case, necessary filters such as Butterworth and Notch are applied over MATLAB. All algorithms have been tested and used 2000 trained data and 200 test data in all. Multilayer perceptron. Multilayer neural network consists of input, output, and hidden layer. The most important reason for choosing this algorithm is that it is multilayered. In many projects, a single neural structure is insufficient. More effective performance can be seen in neurons that can operate in parallel. Accuracy is 92.5%. Support vector machine. It's aimed to differentiate the two classes we have, with and without heresies, with the help of the decision function obtained using trained data. While doing this, a boundary line is drawn on the linear support machine at the closest distance to both classes. The reason for such is kernel in order to get high accuracy. Accuracy is 9.55%. Nearest neighbor classification. This algorithm is an algorithm that classifies a data to be classified according to its proximity with previous data. The number of neighbors to be selected is very important in this algorithm. Although the most effective value of K is different each project, it has shown the highest accuracy is one in the data of this project. Accuracy is 90.5%. Naive Bayes classification. The way the algorithm works calculates the probability of each state for an element and classify it according to the one with the highest value. The reason for choosing this algorithm is because it is known that it performs effectively in limited data. Accuracy is 75%. This table shows the comparison of algorithms. When this table is examined, the following result can be obtained. Considering the implementation of these four algorithms, disadvantages and accuracy percentage, it is seen the multilayer perceptron gives the best result. The most optimum results were obtained with hidden layer neurons and renewed weights and bias in structure of this algorithm. Among these four algorithms, the worst result was obtained from the naive Bayes algorithm. Due to the simple structure of the naive Bayes algorithm, the absence of function to optimize it has been effective in giving bad result. It also requires the data pre-processing when there are similar classes such as hard data. Naive Bayes optimization. More training sets should be used. Duration of the training data should be longer. In order to apply the naive Bayes classifier to data sets with continuous feature, one should first discrete those features. Discretization is a process which transforms continuous numeric values into discrete ones. Computer interface. This application will be developed so that the data coming from Android can be seen by doctor. At the same time, this data from here transferred to the MATLAB system and feedback is given as possibility by artificial intelligence algorithm. This possibility is transferred back to the doctor's interface. If the doctor wants, he can record the information here and view the patient's profile at any time. C# language was used while developing this interface.
Mobile application. A mobile application will be created for the digital stethoscope. With the mobile application, all new and old heart data of the patient can be accessed, and the data here will be forwarded to the doctor. In the login interface, it asks the user to log into the system by asking for his password and Turkish identity number. If it does not have an account, it will be direct you to the registration page. If the user wants to register, the user will be asked about her age and the drugs used, as well as the basic information of the user. On the home page, the user is asked if she wants to see her old data or if she attempts new data. If new data will come from the digital stethoscope, it will come to this page and click the Start button to view the data from the stethoscope. If the user wants to see their old data, they come to this page. Below this data, there are comments from the doctor. We have created a table listing everything needed in the product. Product backlog table consists of 4 epics. These are mobile application, communication, digital filtering, and computer application. It has been shown who is responsible for this epic. Details of the epic are given. Then each was divided into epic, task, and score. You can see the screenboard table designed for this project. The distribution of the task has been made and they are classified under the title backlog to the in progress and finished. Our presentation ends here. Thank you for listening.